Hello everyone, myself Junaed Younus and I am here to present our paper titled Automatic Detection of 5 API Documentation Smells, Practitioner's Perspectives. The other co-authors are Mohammad Tawkat Islam Khondaker, Dr. Gias Uddin and Dr. Anindya Iqbal. So, what is documentation smell? They are basically documentation presentation related issues. Unlike content related problems, these bad documentation styles do not necessarily make the documentation incorrect, but make it difficult to understand. For example, here we can see a Java official API documentation that contains many structural info in the red marked area, which are unnecessary and make the documentation difficult to understand and follow. Now, these kind of smells can severely harm the productivity of the developers. Our developer survey shows that 95.2% participants agree that these smells affect their productivity and 90.5% participants think these smells should be fixed. Now, to fix them, automatic detection of these smells is very important. So, this was our main focus in this work. We conducted our study in 3 phases. As it is a new direction of research, we did not find any available dataset of documentation smells. So, at first, we created a benchmark of 5 API documentation smells. Then, we conducted a survey of professional developers to validate our catalog. Finally, we investigated a set of machine learning techniques for automatic detection of documentation smells. For benchmark creation, we first prepared a catalog of 5 smells by consulting the existing literature and online forums and using the concept of code smells. Then we found a set of official Java API documentations with such smells which primarily confirms the validation of the catalog. Then we collected a large number of documentations and labeled 1000 documentations to create the final benchmark. Now, let's have a look at the 5 smells. First comes the bloated smell, which means the description is verbose or excessively elaborate. So, it is difficult to follow and maintain. Here, we can see a very large Java documentation with 780 words. Next is the excess structural info. We have already seen it at the beginning. This type of documentation contains too much structural information or syntax which are unnecessary for the user. Then comes the tangled one, which contains various complex information, so it is difficult to understand and it lacks readability. Next, the fragmented documentation, where the information is scattered over too many pages. Here we can see the documentation is referring to another documentation for details. The last smell is lazy documentation, which does not contain much information. Many times we face such situation where the documentation has nothing more to offer than the function name itself, just like the one on the screen. Here we can see a developer complaining about such documentation. He tweeted that, "Got to love some commercial API documentation, get row enumerator, gets the rows enumerator, no further info." At the second phase, we conducted a survey of 21 professional software developers to validate our purpose, where we showed them 2 examples of each smell and asked whether they agree or not. We also asked them how frequently they faced these kind of smells and how they affect their productivity. We found that most of them agree with our catalog. We can see that 50 to 85% developers agree with our examples of different smells. The survey further reveals that developers face such smells frequently or occasionally, which points out to the importance of solving such issues. We can see that 60% developers have frequently or occasionally experienced lazy smells, and other smells are also faced by significant number of developers. To analyze it even further, we used a bubble graph like this on the screen, where each circle represents a smell and the size indicates the percentage of developers who strongly agree or agree with that smell. The x-axis expresses the percentage of developers who experienced these smells at least once or twice in the last 3 months, and the y-axis represents how severely the smell harms the developer. We observed that all 5 smells are significantly frequent and harmful, considering the size and position of each circle, while the lazy documentation had the most frequent and the most negative impact. Now, at phase 3, for automatic detection of these 5 smells, we investigated these 3 research questions. At RQ3, we experimented the performance of some rule-based baseline classifiers. For this, we used some rule-based metrics such as documentation length, readability metrics, number of acronyms and jargons, number of URLs, number of function and class names, and edit distance between the documentation method name and the description. At RQ4, we investigated some shallow machine learning models such as one versus rest SVM, label power set SVM, classifier chain SVM, and multi-level KNN with both rule-based metrics and bag-of-words features. Finally, at RQ5, we explored 2 deep learning models, BileSTM and BART, which is a state-of-the-art NLP model. For the rule-based classifiers, we worked with different thresholds of metrics such as average, 25th percentile, 50th percentile, 90th percentile, and so on. Now, if the documentation length is more than the length threshold, then the rule-based classifier labels it as bloated. If the number of method and class names are more than its threshold, then the model labels it as excess structure. In such way, other smells were also detected based on different metrics and thresholds. The rule-based models showed poor performance in general. Here we can see the performance of rule-based model with average threshold, where F1 scores for most smell detection is near 0.5. The threshold of 90th percentile is better on bloated detection. However, it is still poorly performed on other smell detection. The shallow learning models perform better than the rule-based models. Among them, OVR SVM, that is one versus rest SVM, performs the best. With rule-based metrics, it achieves F1 score of 0.88 at blotted, 0.9 at lazy, 0.31 at excess structure, 0.61 at tangled, and 0.37 at fragmented smells detection, while with bag of words it achieves F1 score of 0.74 at blotted, 0.91 at lazy, 0.48 at excess structure, 0.56 at tangled, and 0.55 at fragmented smell detection. Our deep learning models outperform all the previous models. The BileSTM model achieves F1 score of 0.65 to 0.91 on defined smell detection, while our best model, that is BERT, achieves 0.75 to 0.93 F1 score on various kind of smell detection. Now let's have a look at some existing works related to our research. Aghajani et al. Mentioned that documentation problems can be of two types. They are what means content related problems and how means presentation related problems. Trude et al. Mentioned that not all documentations are equally readable. Recently, Uddin et al. Introduced 5 documentation smells, and Aghajani et al. Talked about the necessity of automatic detection of such presentation issues. Several researchers have focused on automatic detection of content-related issues and documentation creation. For example, Rabbi et al. Worked on detecting code comment inconsistency, and Souja et al. Worked on detecting deficient documentations using topic modeling. Then McBurney et al. Worked on natural language summary generation of source code. Aghajani et al. Worked on adding description of API methods. However, very few existing works actually focused on documentation smells or presentation related issues and their detection. In summary, from developers' feedback, we understand the necessity of the automatic detection of documentation smells. So, we created a benchmark of 5 documentation smells. We conducted a survey which shows the developer agreement with our proposal. Finally, we investigated a set of machine learning algorithms for automatic smell detection where the best model, BERT, achieves 0.75 to 0.93 F1 score on various smells. That was all from me. Thank you.